Hello, thanks to the recent bit of issues with David Weiss's Flat Earth Clock app, I thought I was going to go back and reevaluate a few things now that I have the source code available. And one of the things that I wanted to do is I wanted to see just how good of a job I did figuring out the algorithm that the developer used to calculate the position of the sun. The app was available for iOS, and I wrote an app that would look at each individual frame and figure out where the sun was on the clock. And then from there, I was able to derive some sort of pattern as to how it went about calculating the position of the sun for any given day. When I stepped through it with the little speed control at the bottom, I recorded a year's worth, and then later on I wanted to see how that compared against the proper day, and I saw some interesting discrepancies that I couldn't account for. I had done this back in 2002, and the animation went from most of July 2022 to 2023. I noticed a few odd little discrepancies on a couple of different days. And I found it very weird, quite bizarre, that at least on the iOS version, the sun would move at half the speed that it should have. And then on the 21st or the 22nd of every month, it would then jump to kind of catch up. And as you can see, the last time I modified this document was back in 2022. And I had kind of figured that the red line was probably where the algorithm calculated the sun, and that for some odd reason, for the iOS at least, it would end up resynchronizing once every month, but it was really only about half of its proper value. Also, at the same time, I was trying to figure out how they calculated the position of the moon, or even the phase, and the phase was fairly simplistic. It looked like they were using 29.53 days per month and then doing some sort of calculation to figure out what the phase was from there. One of the other things that I noticed, and I didn't really make a video talking about the problems that I've seen with the moon, but it seems that every so many days, the app stays on the same phase for 2 days in a row. And I tried all sorts of different algorithms I could think of just by trying different numbers out, and I could not get it to line up exactly. I was thinking maybe there was a time zone issue, maybe there was some third or fourth decimal place that I wasn't taking properly into account, but I tried all sorts of things to come up with the exact algorithm that they were using to calculate the position of the moon, and I got it pretty close but not exact, and so I kind of gave up on that. And finally, with the source code available, at least for the Android version, I was able to confirm a lot of conclusions that I had drawn earlier. This is a decompiled version of the class that determines exactly where things should be drawn for the analog clock. And the bit about the sun is done more or less over here. And rather than try to tie this somehow into Java Swing, I decided to just output these different commands in this one over here. So this is pretty much a working version of this. And one of the main differences, for example, is that instead of doing an actual rotate, I just log the rotate values that were passed in to the original rotate command. So it's no great surprise how this works. The developer got the day of the year and added 10 to it. And then depending on the value of that day of the year, calculate a slope down or a slope up, or vice versa. The variable d5 is used directly in the translate of this overlay, which draws the sun. So this should theoretically draw the sun over the hour hand needle. And in the original code, they were doing a translate, which would move this up or down so that whenever they drew the sun onto the canvas, it would move this at some different distance from the center. And then they would rotate the entire thing, hour hand, needle, sun, and moon. So with a direct access to D5, I calculated the daily position for an entire year and got the translate value. And you can see that I got very, very close to the original. In fact, the original had this little hook in here as well, which kind of went beyond a certain value. If minus 50 is supposed to be over the equator, 0 should be over the Tropic of Capricorn. Minus 100 should be over the Tropic of Cancer. But it turns out that the December offset is a value of 4 more than the other one. And then finally, what about the moon? I made a few slight changes to the code just to get it to compile, but I did keep the essence of the code intact. And I'll let you look at this yourself for a few seconds. This code is fairly indicative of somebody's prior experience in coding, and you can see that it is not exactly the most efficient. I suspect what they're doing here is they're calculating the number of days in the Julian calendar, then they're subtracting this value. Since they're only looking at year, month, and day, it will jump from one day to the next, and there is no gradual transition from one phase to the next. Subtracting a certain amount and then dividing that by 29.53. Then they're taking the entire value and they're converting it to a string. Then they're going to create a brand new string starting with 0 point something. Then they're looking in that string for the period. Here they're basically chopping off everything up to and including the last period. Here they're just doing a check, I guess, to see if there was or was not a dot, and this should always contain a dot, so this code should never really kick in. Here they're taking the new value, converting it back to a double, multiplying it by 28, and then casting it back to an integer. Because this is never going to be as high as 1.0, this will never get to be 28. It'll always be 27 point something or smaller. And so this code is also redundant. If I had to do it, I would do it this way. I would calculate the original as here, but I would keep it as a double, and then I would subtract the floor of that, which would then basically only keep the fractional part of it. Then I would multiply by 28 and then cast it back to an integer. This method was called by the set moon phase test method, which was called over here to get the moon's phase. And this is about where the canvas was rotated relative to the hour hand to draw the position of the moon on the clock. So in this spreadsheet, I decided to re-enter the formula used to calculate the position of the moon. And in this column where there is a 0, that would be a duplication of the moon's phase. So it should go from 0 to 27 and then cycle back to 0. But there are a couple of days pretty much at every month where it repeats. And the specific month where it repeats very possibly depends on how many decimal places the code has programmed into it. So having seen the code and how well the app was written, it's obviously no surprise to me how and why David Weiss is suddenly facing issues with the application leaking personally identifiable information, and why it's taking them so long to plug all of those data leaks. They will essentially have to rewrite the entire API if they want to make it a half-decent app that doesn't leak user data without explicit user permission. So that brings me to my next logical thought, which was, how can we use David Weiss's current misery as a learning experience? I've been mulling over a few ideas for the last at least 6 months now, and I thought perhaps using David Weiss's Flat Earth Clock app as a learning exercise could be a good launching point for me. So the idea that I had was, I already built my own Flat Earth Clock app. This was my own way at laughing at David Weiss's attempt at building his clock app and how his was not accurate. He doesn't show an analemma. At best, he just shows the sun going back and forth between the two tropics. He can't even seem to stay within the boundary of those tropics. It's clearly demonstrable that the sun does not cross your local zenith at the exact same time every day throughout the year. So having had access to code previously written that uses globe Earth math, I decided I was going to write my own clock app. And the idea here was that if I could eventually be motivated to port this to Android, then this app could then be installed on a tablet or whatever, and it would be some form of desktop app that somebody could run. In terms of recreating what David Weiss has already done, I've already done this part. That's easy enough. I've even added my own form of calendar, with this being January, this being February, March, April, May, all the way over to here. We can see that we just started November. This is going to be December 1st, and this is back to January 1st. So I essentially used the solar system as the date portion, and I used 24-hour clock over an AE map, or you could project this over anything else for the time. I made a few videos already where I described how I thought I could represent the time with a spherical Earth projection like this here. And I got the idea to do this as if you're looking at the Earth with the star field rotating around you. And if I projected each of these stars in 3D space based on parallax, it would either be resolvable as a proper numerical display, it would quickly distort and become just a blur of unresolvable star patterns at this kind of angle. I added this as well, and I have several other projections that I've included. I kind of broke this one. At one point I had this so that it would shift the map and allow you to have your local position in the middle, and I would need to fix this up. I already have the Flat Earth Clock app part done already, and I thought that I could expand on it. It would not take me much effort to add Spring Boot and Jetty to it so that I could make it a web server as well. If I made this as a web server, I could then support a regular browser with JavaScript. I could then use the client's computer to animate very specific parts of it, such as the clock. And in certain cases, I could limit the number of background image refreshes, which I would then probably leave on the server side to do. And the idea would be that I could then show the process of developing essentially what David Weiss already has in his thing, but done sensibly, such as implementing proper security in the API. And if we want to stick it to the flat earthers, we could also implement our own version of resources, such as providing a video library of videos that debunk flat earth. Other resources, such as web pages that go, let's say, for example, to mctoon.net, or other resources. Some people on the platform formerly known as Twitter are also starting to make their own memes showing just how silly flat earth is. So if we decided to use this opportunity to create our own version of David Weiss's Flat Earth Clock app, we could use it as a way to share resources to hopefully help educate flat earthers and to give them solid evidence and reasons as to why the earth is not flat. I want to gauge people's interest in this before I commit to too much time or effort. I am starting to feel a little bit old and tired as time goes on, and this is genuine work. So for me at the moment, I would feel more inclined to demonstrate the process of how to go about implementing these things. How would you write a Spring Boot application, or write an application that you could then load, let's say, into Tomcat? How do you create API endpoints that are secure? Hook up a database, design the database, come up with a relational database of some kind. All that information could then be presented in a sort of how do you go about coding this kind of thing. I would certainly feel more comfortable if I could get other like-minded developers to help me with this task, if the goal is to come up with a usable application. At this point, I may not be interested in writing the application myself as a finished product, but really just to demonstrate the process. And that could then be sort of an introduction video or series of videos as to something that I had in mind at least for 6 months now. We just finished a project at work that was essentially to replace a previous app that I kind of cobbled together due to business requirements, and we didn't really know exactly what needed to be done. It had to take a whole bunch of different sources that were formatted in all sorts of different ways and parse them differently and to render them into a common template. And what I thought was going to be a temporary project ended up lasting for 10 years. And then finally, eventually, we had to redesign it. And that project redevelopment started with a document that tried to convince other teams to buy into it. The process itself was very good at defining clear objectives and clear goals. And it's a very good way to show how careful planning goes a long way to save a lot of work later on. And we can go back to David Weiss and the A-team. So he basically hired the A-team. So a good amount of careful planning can help eliminate having to hire the A-team to fix the mess that was made years earlier. In the process of making these flat earth related videos over the years, I found that I could make very good use of two specific applications. One application idea that I had was to create a half decent voice recorder that could be synchronized with a script. It would automatically stop recording, or it could automatically split the audio into different segments when you're quiet and you're thinking of what you're trying to say, be able to export an audio recording, mostly edited in the app itself with hardly any effort at all. I had a few ideas for that. It would include different takes. So if you mess up a part of the script, you could, with a few keystrokes, you could tell it that that was a bad take and that it would record a new take, etc. There are a lot of things that I thought of adding in there. If you had two microphones, it could even create a script that you could then feed through something else like FFmpeg. And if you were doing a screen recording, it could automatically split and trim your video for you, doing a lot of the pre-editing work that could hopefully save you a lot of time when you load it into a real video editing software. That was one of the first applications that I thought could really help me. And then the second one that I thought of was I've been going back through my stuff and picking out various calculators that I had accumulated over the years. And of all the calculators that I've had, the one that I found that I really liked, that I just thought was the best one out there ever, was the one that I had for college. And I kind of missed the simplicity of that kind of calculator. And I thought of writing my own calculator app for the desktop. It would be fully programmable. You could apply different skins to it. So you could have one calculator app look and appear like any specific calculator you wanted, with hopefully just a bit of programming. And so that was one of the directions that I was hoping to go. For those who might be interested in programming, who might be interested in the process of programming, to show all the various steps required and basically give people an idea of different pitfalls, different design considerations, etc. And sort of in a way to push back on this whole idea of just having AI solve all of our technical needs. I have a few ideas on AI that could take hours to go over, and I don't want to do that in this video. So if you made it this far, I thank you very much for at least watching this much of it. And so I am formally asking people's opinions. Please leave your comments on this video. Let me know what you think of this idea going forward. Anybody who's followed David Weiss and his Flat Earth Clock app saga know that the developer that he chose was probably fresh out of school and didn't really have any kind of experience, essentially falling into a lot of different traps that culminated in a mess of insecure and buggy code. I think that it would be a good idea for those who are interested in computer and application security to have a real-world example of how to design something right with a lot of the industry best practices baked in from the start. If enough interest is generated and there's enough people helping me move this forward, we could possibly end up having a usable application, and then we can maybe get the likes of FTFE or MC-Tune or some of the other flat earth debunkers out there to help maintain a library of resources that we could point flat earthers to as we engage in them on social media, for example. And unfortunately, unlike David Weiss, I'm not a used car salesman, and this is about as good of a sales pitch as I can make. I'll leave it there for now. Thank you for watching. If you liked the video, of course, you know what to do. And with that, I'm going to see you again in another video, hopefully soon enough. Bye for now.